In this presentation, we will investigate the modern periodic table. In fact, the periodic table works perfectly when the elements are arranged in order of their atomic number and not atomic mass. What's the atomic number? Remember that the atomic number of an element tells us how many protons are in its atoms. Actually, at the time of Mendeleev's discovery, scientists knew very little about the structure of an atom. So this is the modern periodic table. This is hydrogen, this is helium, this is sodium, this is phosphorus, and argon. So now these elements are organized in the periodic table. So let's take argon as an example. Argon was discovered in 1894, which is gas at room temperature at 20 degrees Celsius. It's an extremely inert or unreactive gas, and it's often used as an atmosphere to stop other materials from reacting. What does these two numbers over here indicate? This number 18 is the atomic number, which is the number of protons, which is equal to the number of electrons in an atom. And 40 is the mass number, which is the number of protons and neutrons. We will describe later the periodic table in more details. Decide whether the following statements about the atomic number of an element are true or false. So read each of these statements and label it as true or false. Excellent. So the atomic number, Z, can tell us the element's position in the periodic table, and it's equal to the number of protons inside the nucleus, which is equal also to the number of electrons in an atom. However, pay attention that the atomic number isn't the number of neutrons, and it's not equal to the number of protons plus neutrons of an atom. Now we will describe groups. The vertical columns in the left-hand and right-hand blocks of the periodic table are called groups. There are 8 groups in total, which are numbered as shown below. So this is group number 1, which is called the alkali metals. All elements in this group have 1 electron in their outer shells. Group number 2 is called the alkaline earth metals, and all elements in group 2 have 2 electrons in their outer shell. Elements in group number 3 have 3 electrons in their outer shell. Elements in group number 4 have 4 electrons in their outer shell. Elements of group 5 have 5 outer electrons. Elements in group 6 have 6 outer electrons. Group 7 is called the halogens, and all elements have 7 valence electrons or 7 outer electrons. And group number 0, which is sometimes numbered as 8, are noble gases. These are very unreactive because they have full outer shells. Over here we have the transition metals, and here we have the rare earth metals. So you have to keep in mind that the number of the group is equal to the number of outer electrons. Let's now describe periods. The rows across the periodic table are called periods. We read the periodic table row by row, starting at the top left of the page. So there are just 2 elements in the first period, which are hydrogen and helium. The second period starts with lithium and finishes with neon. So this is period number 1. This is period number 2. This is the third period and period number 4. The period number is equal to the number of the electron shell. So for example, elements in period 1 have only 1 electron shell. Elements in period 2 have 2 energy levels or 2 electron shells. Elements in period 3 have 3 energy levels.